So question number 10, the smallest fundamental particle of an element that has the properties of that element is, well, of an element, it's not the proton. Proton is used to make atoms. The neutron is used to make atoms. Electrons are used to make atoms. And depending on what ratio they come together in, fixes the identity of that atom or element. So in this case, the only choice is the atom. So question 11, which of the following statements or conclusions is not a component of Dalton's atomic theory? Now, there will be a fraction of the exam that are like this, knowledge questions. You need to just know the information and then give it back to me. Let me know that you know it. And in this particular case, you have to stress that this is not a component of Dalton's atomic theory. So 3 of these will be Dalton's atomic theory and the other one will not be, and that's your job to identify. So chemical reactions are merely the rearrangement of atoms. That's definitely true, right? That is what Dalton says, so that's true. Matter is composed of small indivisible particles called atoms. That's Dalton's theory. This last one, atoms of the same element are identical and have the same properties. Not true, but it is one of Dalton's ideas. Same with the second one there. So that leaves only this one, any 2 elements which will always form the same compound. Not true, not Dalton's theory. Question 12 is another knowledge question. The area of the atom that contains the largest mass and is the most dense. Now it is the largest mass is what it's focused on here. And really in an atom, the only part that contains any mass that we count is the nucleus. The proton and the neutrons are located in the nucleus, and therefore that's where the mass is contained. And also, because it's in such a small area, it's also dense. It's the most dense. And that's the answer to question 12 then. Question number 13, the nucleons located in the nucleus of an atom are a combination of which of the following? So it's asking the question, do you know what nucleons are? And nucleons are the particles that are contained in the nucleus. And that, of course, is both neutrons and protons. And that's the only one that fits here. Electrons and neutrons, no. Neutrons, yes. Electrons, no. Protons and electrons, protons, yes. Electrons, no. Protons and alpha particles, no. Neutrons and protons are the best answer. Question 14, the mass number of an atom is equal to which one of the following? So mass number, let's first of all identify what that is. Remember, to have a mass number, we have to be in isotopic notation. So there would be our symbol, whatever the atomic symbol is for that. And then the mass number is in the upper left-hand corner. The atomic number is in the lower half. And then the charge, whatever the charge of that species is in the upper right-hand corner. So the mass number is not the atomic number. And remember, the mass number contains anything that has mass. So that's going to be the protons plus the neutrons are what are contained inside there. These are identified to be the nucleons. Protons plus neutrons are the nucleons, the things found inside nucleus. Okay, I couldn't get the actual symbol here to transfer, so I sketched it in. And what is the identity of this species right here? And again, we indicate, or by the way it's drawn, we're talking about isotopic notation, so consisting of 2 parts, the mass number, which tells us very little, but the atomic number tells us the number of protons, and that tells us what the identity of the species is. So if I switch over here, I go down here and I look for atomic number 99 down here, ES, Einsteinium. Doesn't tell us what the mass number is, doesn't have to, because we identify elements by their atomic number and the number of their protons. And in this case, that is Einsteinium. That's question 15.